Okay, so members, today we are going to see the latus rectum to a hyperbola and then also equations of asymptotes to an hyperbola. But please don't forget to subscribe to the channel. Now, if we start with, we know that the latus rectum is a chord that joins, of course, two ends of a hyperbola. But now, the latus rectum specifically is going to be passing through the focus and it's perpendicular to the horizontal axis, as you see here. It's passing through the focus and it's perpendicular to this horizontal axis. So that's what we call a latus rectum. So we know if you get the same and multiply it from here, this is what we get. Now the latus rectum at this point F, where x is AE. So if I substitute here AE, I square that. Now it's that when I expand this, it's going to be this, and this square comes to this. So now from there, a squared is common. Divide through by a squared, there, and there. Then this y is that b squared is common here and here. If you factorize it out, it's that you have such thing. But we know that for such an ellipse, we know that how to get the eccentricity, we use this condition. So we get the eccentricity using this condition. So I'm seeing it here, so I want to remove it. So if I divide this side by this one I get. So from here now, if I put here and where there is this, I put this one I have the power 4 over s squared, then the square root of y is equal to 2 plus or minus that. Meaning, now to get this coordinate where it joins these 2 points, remember it's passing through the focus and the x values here. So this one is AE, and this one is, because it's the same value of x, is AE. But now, the value of y here, we have seen, we have to, the positive by negative, of course the positive that is up, the b squared over a, and then here is negative b squared over a. So from here, I can get the length from this point to this point. So it's that the length of b, AB, will be now, I'll be just getting b squared minus b a. So I get this minus this. So that this length will be now 2b squared over a. And members, this is the length of the latus rectum of a hyperbola, and it's the same as that of an ellipse. Now we come to the asymptotes of hyperbola. Asymptotes, these are lines that a curve never touches at any one point. So you see that when we are sketching our hyperbola, there are these lines crossing like this. So you see that always this curve never touches these two lines. So we want to determine what are those equations. So from here, you see we are going to determine them from here, those equations of asymptotes, that as the curve approaches a certain values of x, the curve should never touch them. So when I take this side, and I bring one this side, I'll be having now x squared over b squared. When I take this side and I bring this one this side, if I multiply through by b squared, I have b squared twice squared, multiplying through by b squared, this squared here, and there. And from here, so that now my y squared, this y squared, is that b is common. Now, if I factorize out now, look at this factorization. Okay, is equal to b squared, x squared over a squared minus b squared, because it's an equal step. Let me write that there. Now, if I factorize the whole of this out, I'll be having y squared equal to b squared x squared over a squared. If I remove that out, here I remain with 1, then minus, I'll be remaining with now a squared, this goes up, then this comes down like that. This b will divide by this. So if I factorize out this, what I do, what we factorize, you just get this, you divide it here, you get 1. When you get this and divide it here, this b will cancel with this b, then this will go up and this will go down. In simple terms, what you remove, you divide it there. So that's how we factorize that. Now if I get the square root, both sides, is that my y will be now the square root to this side, and then the square root to this side, so that we have in y equal to 2. Here we have in plus or minus b over a, then x, then under square root of 1 over x squared. And from here, if we put a condition that as x tends to infinity, you see that now a over x will tend to 0. Why? Because if we have 1 over something big, this one is always and a 0. So now, that always now from here, because if now this is 0, it means that even its square is going to be 0. So the whole of this will be 0. So 1 minus 0 is 1. Square root of 1 is 1 times this. That what is arriving with is minus plus bx over a. And now these are the equations of that asymptote. Why do we take to infinity? Because of that, we need the values of x that will push this curve to infinite values. So the curve should never touch them. That's why we put in these conditions. So now we have this one. So from there, we can see that we have them as y equaling to b over a, x the positive, and then the other one, y equal to negative b over a, x. And if you see here, the one which is positive, this is the line. So y equaling to b. And then the one which is negative, this one is having the negative slope. Negative b over a, x. So members, that's how we get the equation of asymptotes to a hyperbola that, and also the length of the spectrum to that hyperbola. I wish you the best and sign out.